Hello friends, welcome to Learners Forum. So this video is about rectifiers. So before starting with the topic about rectifiers in detail, we should know the basic meaning about what is a rectifier. So instead of speaking about electronic term, let us see the literal meaning first. So rectifier in the sense, we always say we rectify our mistakes, which means it is nothing but correcting the mistakes. So correcting the mistakes is called as rectification, and the thing used to correct the mistake is called as rectifier. So mistake in the sense, here we are going to consider a signal. Let us consider a signal in this particular wave, which means it is moving here and there. So we have to correct the mistakes and convert this signal into a straight line. So here we will not have the wave flowing outwards, that is here and there. So here it is moving in a linear way. So when this wave is converted to particular wave, that is with a linear movement, here we call this wave is getting corrected, that is this wave is rectified. So the process in between which converts this particular wave into a linear wave is called as a rectifier. So we call this signal as a AC signal and this one as a DC signal. So whenever we have to convert a DC signal, that is AC signal, into its equivalent DC signal, then we use a device called as a rectifier. So rectifier is a device that converts AC voltage into pulsating DC voltage using one or more PN junction diodes. So here the process is converted from AC to DC, but we have in terms of pulsating DC. So once after seeing the basic circuit operations, let us analyze what is the difference between a DC signal and a pulsating DC signal. So here we will be using one or more PN junction diodes. So this is the basic process that occurs in a rectifier. So PN junction diode, the reason for using in a rectifier is PN junction diode conducts in one direction, that is when forward biased diode conducts, and whenever it is reverse biased it does not conduct. So current flow occurs only whenever this particular junction diode is forward biased. So when an AC voltage is applied across a PN junction diode, two things will occur. That is, when it is positive half cycle, the diode will be under forward biased condition and it conducts. So we will have the flow of current here. So whenever negative half cycle is happening, the diode will be in reverse bias condition, which means it does not conduct. So there will not be any flow of current over here. So in this condition, when a resistance is connected in series with the diode. So first we saw about what is the working operation of a diode. And then we saw about what happens when an AC voltage is applied across the PN junction diode. And for the third condition, we are going to add a resistance in series with this particular diode. So under this condition, the output voltage will be unidirectional, which is nothing but the required DC. So here we have applied an AC voltage and that is converted into DC here, which means this is the working operation of a rectifier. So rectifier converts AC voltage into a DC voltage, where we have used a PN junction diode over here. So this is the basic operation. Now let us see certain characteristics about this particular rectifier circuit. So under the characteristics of rectifier circuit, the first one is about the waveform of load current. So load current in the sense, the net output is going to be the current across the particular load that we have connected. So this load current waveform has to be analyzed, because when a rectifier is used, the AC is converted into DC, which means there will be variation in the waveform from the input to the output in. So we have to analyze the particular waveform of load current. Second is regulation of output voltage. Again, when there is a variation across each particular elements, say if we are using a diode, there will be voltage regulated over here. So in that condition, we have to check the regulation of the particular output voltage also. Third is rectifier efficiency. So how much output we are obtaining and how much input we have applied. The ratio will be taken under rectifier efficiency. So we have to calculate the efficiency based on which we can detect the performance of the rectifier circuit. Fourth and fifth is peak value of current and peak value of voltage. So peak value of current will be calculated in the rectifier circuit, whereas peak value of voltage will be calculated across the rectifier element. So here we are using the rectifier element as diode. So across the diode, when we are calculating the peak value of voltage, that is also to be included under the characteristics. Whenever it is rectifier circuit, we will be calculating the value of peak value of current across the load which is connected to the circuit. So this is the ultimate difference between peak value of current and peak value voltage. So peak value of current is taken across the load, whereas peak value of voltage is taken across the diode, which is nothing but the rectifier element. And the last one is ripple factor. So less the value of ripple factor, better will be the performance. So these are the characteristics of rectifier circuit. So when we talk about peak value of voltage, when diode is not conducting, the reverse voltage will be applied across the diode. So in that condition, the value of voltage will have a peak value, and that is called as peak inverse voltage. So that is the value of voltage obtained over here, that is across the rectifier element diode. So these are the characteristics of a general rectifier circuit. The basic thing we are supposed to remember is what happens when we use a rectifier. So it is nothing but conversion of AC into DC, and in particular it is pulsating DC. So we have seen about the characteristics of rectifier circuit also. Now let us see the types of rectifiers, which includes half wave rectifier, full wave rectifier and bridge rectifier in detail along with the required parameters.